We expect autonomous AI to operate with flawless precision. We want it to book global supply chain logistics, parse sensitive medical histories, and route complex data packets without human intervention. But then the system drops a critical database. Servers freeze. A supposedly intelligent agent wipes an entire directory in seconds. When this happens, the tech industry usually falls back on a convenient excuse. They claim the AI hallucinated, treating the model like a confused brain that simply made a random mistake. Catastrophic agentic failures are predictable, mechanical flaws in the system's design, the direct result of too much autonomy meeting too few constraints. Writing off a deleted database as a mysterious quirk of artificial intelligence ignores the actual threat. The real danger is granting unconstrained autonomy to a system without the architecture to control it. An agent goes rogue because it is handed massive capability with virtually zero structural boundaries. Harnessing an autonomous system requires subjecting it to the same strict back-end engineering principles used for any enterprise software. Treecapital AI built the Anven ecosystem specifically for this reality. Operating as a sovereign intelligence layer, Anven replaces the chaos of open-ended generation with highly orchestrated deterministic rules. Scaling AI in high-stakes environments means replacing blind trust with precise, unyielding architectural control. Consider what happens when an agent is asked to locate a document that simply doesn't exist. Instead of stopping, the agent endlessly searches, replans, and retries, burning massive amounts of compute resources for an impossible task. This infinite loop occurs because the agent was deployed without a termination condition. It lacks the internal logic to measure its own progress or realize there is no exit path. Anven neutralizes this risk through agentic retrieval augmented generation, binding the model strictly to your private, verified enterprise data structure. This diagram outlines Anven's prompt engineering and logic control architecture. The model explicitly states insufficient data to prevent result fabrication when information is missing. Autonomous agents are only safe to deploy if the architecture explicitly tells them exactly when to stop. The second major failure mode is hallucinated planning. This is when an agent outlines a strategy to book flights while ignoring the fact that it has zero access to the necessary travel API. The system fails because the agent assumes its own capabilities. It drafts the plan without cross-referencing its programmed constraints or verifying its tool schemas. Anven solves this using LangChain orchestration and multi-agent workflows. Before the primary agent can execute a single step, a specialized secondary verifier node intercepts the plan and cross-checks it against the approved rules. A well-reasoned plan becomes an active liability if your system design doesn't mandate a hard mechanical barrier between the planning phase and the execution phase. The most severe failure occurs when an agent tasked with a routine cleanup operation accidentally wipes an active, mission-critical database. This happens because the agent is wielding overprivileged tools. The system designer gave the agent broad database access without distinctly separating read, write, and delete permissions. Anven enforces the principle of least agency. Every tool operates within a strict digital sandbox, and access is tiered, so an agent can only pull the specific levers required for its immediate task. For irreversible actions, Anven requires an explicit human-in-the-loop approval workflow. The system pauses the execution and waits for manual input before processing the command. True autonomy in enterprise environments relies entirely on absolute, mechanical restrictions on what a system is allowed to destroy. When you move into global defense, finance, and healthcare, the stakes multiply. These highly regulated sectors cannot tolerate probabilistic mistakes or open-loop experimentation. Beyond simple error correction, these industries demand absolute data sovereignty. Every piece of proprietary intelligence must be mathematically isolated from external vulnerabilities. This graphic illustrates Anven's access and operational readiness. It states that transitioning to Anven architectures returns control to the enterprise, operating entirely within an air-gapped virtual private cloud. Enterprise AI becomes a secured digital asset, engineered to live behind a firewall where data remains isolated. Deploying AI as a chaotic experiment is a liability that enterprise infrastructure can no longer afford. Building a secure competitive edge requires engineering proprietary data into a private intelligence layer that your organization fully owns. Precision system engineering provides the architectural control necessary for autonomous agents to perform high-stakes work.